A critical yet challenging component of wildlife science is to estimate the abundance and distribution of animal populations, as they are essential to understanding the current status of species and their population trends. The authors of this study, published in 2011 in the Journal of Wildlife Management, aim to estimate the abundance of the pygmy rabbit through the development of an index of abundance. The authors developed an index of abundance based on the use of burrow systems because pygmy rabbits are obligate burrowers. To prove the success of this index, the authors hypothesized that the density of rabbits would be positively related to the density of active burrow systems, and that the study areas with greater shrub cover were expected to support greater densities of rabbits. This study was developed at 7 sites in southeastern Idaho that were approximately 100 hectares and were distinguished by mimmer mounds supporting dense thickets of sagebrush. All sites varied in the density of burrow systems. Table 1 illustrates that the activity status of all burrow systems was evaluated and placed into 4 categories: active, recently active, old, and very old. Table 1 further indicates that the systemic burrow system yielded density estimates that differed across all sites, with the number of active burrows ranging from 0.19 to 3.46 burrow systems per hectare. The authors used mark resite techniques of 80 radio-collared rabbits to estimate population sizes on 4 high-density sites, and conducted snow track surveys on 3 low-density sites and 2 high-density sites. The results obtained from the methods indicated in Table 3 revealed that the estimate of rabbit density varied across sites, whereby estimates ranged from 0.02 rabbits per hectare to 0.46 rabbits per hectare. This means that rabbits occupy more burrow systems when burrow density was higher. Thus, the number of burrow systems used varies with the density of available burrow systems. The authors measured spatial distribution of burrow systems and patterns of burrow systems used by rabbits in order to test the relationship between burrow use and the density of available burrow systems. Figure 2 indicates that a positive linear relationship between the two was obtained, therefore supporting the first hypothesis. However, as indicated in Figure 1, the analysis of burrow use supported a nonlinear relationship between the abundance of burrows and pygmy rabbits. This indicates that the population density of rabbits increased at a slower rate when density of active burrows increased. Results also from the vegetation survey revealed that they do not fully support the second hypothesis. This study allowed the authors to come to the conclusion that the density of burrow systems can serve as an index for monitoring abundance and population trends of pygmy rabbits.